Welcome back to our last part of a network layer module, and this one is a small follow-up to the previous discussion, but with a slightly different angle, and I'm going to be talking about virtual private networks. So first of all, what the VPNs or virtual private networks are for. There are multiple uses of VPNs, and one of them is simply try to connect different private, like literally different private networks to over public internet. So for example, if you have two offices somewhere far away, one in Beijing, the other one in New York, and you want to have very private conversation kind of between these offices, but you don't want to basically build a dedicated fiber link between two cities because it's quite far away. So what you can do, you can use normal IP internet, but rather create some form of a tunnel, logical tunnel between these offices. And then this is the job basically of VPN, to transfer packets from one side of the tunnel to another side of the tunnel in some secure fashion. So actually for you it's transparent that you communicate in kind of with a remote office or with a local office. And the VPNs can do various types of jobs. You can do IP level VPNs, and you can also sometimes have even lower layer VPNs, like layer 2 VPNs. So this is what about institutions. In addition, what you can do with VPNs is not necessarily connect two different big offices, two big networks, but rather connect one host to the network. So for example, if you're an employee in some company, then they usually require you to VPN to the network to access some private resources, for example, some payroll information. So that would be another use of the VPNs. And finally, this is kind of the most common use today, is it somehow to do the private internet browsing. In this case, you as a user connect to the VPN server that kind of somewhere far away from you, or close by to you, doesn't matter where exactly. And then you simply encrypt all the traffic from you to that VPN server, and for the rest of the network, you you present itself as that server. In some sense, it looks a little bit like a network address translation, but in a different level. So with network address translation, it's just a router in the middle hiding you, like whether you're willing to do that or not. With VPNs, you selecting a server that you will be hiding behind, and then that you kind of for the whole world you represented by that server. This slide highlights the concept of connecting two offices, and as you note, there's this again private address ranges that we already used before during the network address translation lecture, but now they actually used as they designed for. So they were actually designed for the private networks that can be connected over global internet and not being routed or being communicated in any other kind of reason. So the way we're using it with NAT is actually not the way they're supposed to be. A core idea behind the all VPN solution is some form of a tunneling. And so for example, it can be done in simplest case as a simple IP tunnel. And what you can do as a guy that wants to send a packet across the network is simply create a packet that you want to send. So for example, if you are this 10.2.1.1 and you want to send a packet to a server that is far away and it's 10.3.16.1, so your job is simply to create that packet. So that's it. And you don't do anything special. Then the job of some module, either inside the operating system or some remote modules, for example, in this case, it can be the router one, is to simply add additional header on top of it. So what you can do is simply create a new IP packet, and that IP packet will have a kind of public IP address of the router as a source, public IP address of the router on the other side. So it will have a public IP address of the router as a source. It will have another public IP address of another router closer to that destination as destination, and it will have a payload. And that payload, kind of in the simplest form, is simply another the original IP packet. And that's it. So now we have a legitimate IP packet that, like this one, that all routers in the middle will simply consider as a IP packet with some random payload. So that would be considered from perspective of everybody. As soon as this packet reaches R2, then it will R2 will extract that inter packet, like this one, and it will forward this as normal. So from the perspective of individual networks here and there, we're sending this the internal packet. from the perspective of everybody else inside the internet, they're going to see this outer packet with a payload that happened to be inner packet. So that's kind of very, very basic idea. As I said, this is one simplest mechanism to do IP tunneling. Other mechanisms are simply trying to do different things, how to encapsulate. So for example, instead of doing a simple IP in IP encapsulation, you can do IP in UDP encapsulation, IP in TCP encapsulation. Like we still have original IP packet, but you encapsulate as another IP UDP packet or TCP packet, HTTP packet, or in some weird cases you can also kind of tunnel through DNS. So in this case, you will put original IP packet inside a DNS record, and kind of the other guy will try to figure out how to do this. So these are existing solutions. It's just there are different mechanisms. To highlight the kind of the number of different solutions, I gave you this slide, just highlighting there are different products. Some use the standardized solutions, some implement their own kind of proprietary solutions. So the few standard ones are this L2TP, PP2P, IPsec, and OpenVPN, also semi-standard. But there's tons of others that you may give me as answer to the question that simply give the product, they potentially hide how exactly they implement, for various reasons, how exactly they implement, but the idea is still basic. So you have some form of encapsulation, you do potential encryption of the payload, you do some form of obfuscation of the outer packet, just to pretend that you're not sending packet on behalf of someone, and just do some just simple forwarding of that packet and decapsulation on the other side. That's basically it for VPNs. As I said, VPNs can be used for different purposes. So they were originally designed to connect private networks. Then they start being used in a simplified form to just connect one computer to a VPN network. And today, the most prominent use of VPNs is to basically trying to private browse of the internet, the private connection of the internet. For example, if you don't trust a Starbucks network or you don't trust some hotel network, then you better use VPN. So you kind of encrypt all the traffic from you across whatever this untrusted network to trusted server, and then from that point to point, then your traffic is whatever your traffic. And I just highlighted there are multiple solutions that are available on the market, or and all of them boil down some form of IP in something encapsulation. You encapsulate an IP, just an IP packet in UDP, TCP, HTTP, DNS, and some kind of other random encapsulations. So that's it. We're done with the networking module. There were a lot of parts. I hope they were not too big, some of them bigger than the others. And next we're going to be talking about the link layer module, which I hope is smaller but not less important module. Okay, bye, and I see you next module.